Alrighty, I think that it's time to start. So thank you everyone for coming, and we are already live streaming, I assume. Yes. Right? Awesome. How many people do we have watching? Do we know?
25.
That's not bad. Hi, people. All right, I'm going to start a quick intro before we get Maoni in. So first, I just would like to thank you, the organizing team. We have people like Vojta Mader from the Xamarin Meetup. We have actually Martin over here who helped us and is helping with the live streaming. Thank you very much, because it was a task given few weeks ago, and he succeeded. So, we will see. We hope, at least. Lucia, she was very helpful as well with organizing. I can't see her right now over here, but thank you, Lucka. We had as well David Mali from Xamarin Meetup, and I'm not going to thank myself, but yeah, I helped a little bit. And thanks for Maoni, actually, to our speaker. This is her picture on Twitter, and I found very secret stash of her real photo. Actually, she gave it to me. So this is a real photo of Maoni, not just the one that you see on Twitter. Maybe she will use it. Maybe not. Anyway, Maoni is going to speak very soon. Actually, I want to thank her explicitly because we actually, as you're going to hear soon, there has been hiring event actually starting from Monday. We just finished literally 10 minutes ago with some kind of discussion. So she was one of the interviewees, and when she said okay, we're gonna go be in Prague, so what should I do? Should I do any meetup? I was like, of course. So that's where we are. So it's organized thanks to Maoni. What we're gonna do? We're gonna have this intro is not there, but we're gonna do talk for 1 hour. Maoni about GC 3.0 and beyond, or we're going to be a bit flexible. Quick break, and after that there's going to be kind of panel discussion / Q&A with Maoni and me, so that she doesn't feel alone over there on the stage. It can be about GC, it can be about anything .NET Core, and in the worst case we're not going to be able to answer. So if we're going to try to stream both of those things, hopefully it's going to work. And if not, please, people online, let us know. Otherwise, during the panel discussion, we should be monitoring as well the feedback on the YouTube channel. So feel free to ask questions. We might answer some or not. We will see. And just want to kind of say why. As I said, we are hiring over here, and great news. Actually, I tweeted it a couple of hours ago that the .NET team that we started in Prague. We started first, in summer with first 2 teams, and we're actually expanding that. With .NET tooling teams, including manager roles. So please tell your friends. Please help, retweet. We would really appreciate that. There's information on Prague.net. And just FYI, if you didn't know that we hired, we actually have already T-teams mostly kind of fully hired, and that's networking and engineering services team. So just a heads up. Yes, please take a picture. I like that. I'm not gonna tell who that was. And there's Maoni.
Good evening. So thank you very much for coming here. I really appreciate it. I spent many hours flying here. So since I'm a person, I wanted to sort of amortize the cost. So I asked Carol what else I could do in Prague. Is there any chance to talk to customers or folks who are just interested in GC and GC related stuff, and he very kindly organized this meetup. So here I am. So hi. So I wanted to mention a little story. So my development on GC actually, until end of last year, it was mostly on the full framework on desktop. Internally we call it desktop, right? Externally we have .NET and .NET Core. So for full framework, because most of our biggest customers, most stressful workloads were running on .NET, which meant my development was mostly done on .NET. But until the end of last year, basically I made a decision. I was like, I'm going to officially move my development to .NET Core. So that's when I did this desktop port. And this is mostly from 4.7.x in desktop, because before that, I mostly just sort of did some fixes in core, but it was not really in sync, the 2 code bases. End of last year, this is where we unify the two code bases. So with that, I don't know how many people here are still using .NET versus .NET Core, but I wanted to sort of talk about what that meant to bring over some changes from desktop. So I'm not going to mention all of them, and I'm just going to mention a few. Mostly using this as really an opportunity to explain how things work, right? Because there's many things that I can explain, and I chose these three because I think they provide such good opportunities. So the first one I wanted to talk about is the small and large object heap, the alloc log split. So this is the log for the allocation on the heap. And originally we had one log for both small and large object heap for the same heap, right? Obviously with server GC, there's multiple heaps, so each heap had their own log. I'll explain this in more detail. And then there's new, what I call provisional mode, which meant that it's actually triggering GCs because GC wanted to, saying that until then, GCs were triggered due to some, you could say, external factors, right? So most GCs are triggered because of allocations. So you allocate some memory at some point, according to the GC tuning, GC will say, I'm going to trigger a GC, right? Provisional mode says that during the GC, GC will determine that I'm going to put GC now in some sort of mode that after this GC is done, I'm going to trigger another GC on my own. So I'm going to explain why I wanted this mode. And then there's a few new GC configs. I don't know if people here are aware of the GC heap affinitize mask config. So basically, you could say that I want to affinitize only with specific CPUs. So you can, if you have 32 CPUs or 32 cores, you could say I'm only going to affinitize GC heaps with, let's say, 4 of them. So you could use this config to specify a mask, and then we would only create that many GC heaps, and they would be affinitized with those cores. There's a GC high mem %. I actually could not get this into the runtime JSON because folks in my group said this does not sound like a professionally named config name. It's like, what is high mem? Why is part of the word missing? But that's what I named it. So you can still specify any of these with the complex variable, environment variable. And then there's also GC large object heap threshold, and I'll also explain what that means. So there's some others, but those 3 are what I'm going to talk about today. And you want to know some implementation details? I imagine the answer is yes. So if we're going to talk about the alloc log split, how does login actually work on a GC heap, right? We obviously want to understand that to begin with. So you're allocating on a GC heap. Obviously, you imagine that at some point a log is taken, right? So we have this concept, and I didn't mention this in the book, the Runtime GC chapter. It's called an allocation quantum. So what that means is that GC actually doesn't give out memory each time you call new, right? If you call new some object that takes 40 bytes, most likely that wouldn't actually come to GC. GC wouldn't see that. When GC does give out memory, it gives out this allocation quantum amount of memory, which is usually about 8 kilobytes. So then it hands that off to the JIT code, which will then sub-allocate in that allocation quantum. So only after that allocation quantum is consumed would it actually come to the GC again to acquire more memory. Right. So before 4.7, I think I put this in 4.7.1. So before that, for each heap, right? By each heap, I just mean each heap, if you have server GC, so if you have 4 heaps, then each heap would have its own allocation log. And they share this, the small and large object allocations share the same log. So you might say, well, that doesn't sound very efficient, right? Why would small and large object allocations share the same log? So if you think about the costly part of an allocation, obviously, if it does need to trigger a GC, it would be very costly, right? Most of the time, we do bump pointer allocations if we still have the space, so it's very fast. But there is a costly part, which is we might need to zero out the memory. So that would be our biggest cost, right? That's just a guarantee that the runtime makes, that every time we hand out a new object, it's guaranteed that the memory is zeroed. Actually, in 3.0, we introduced an API, so that's no longer the case, but you can read about that elsewhere. That costly part is actually not done under this allocation lock. So we specifically avoid still holding this lock while that part is done. So right before we call memset, to clear the memory, we actually release the lock. So the actual time the lock is held is very small. And this is, so from the allocation point of view, this was actually not a big problem, or hardly any problem. However, there's one other problem. Oh. Doesn't seem to work anymore. Carol is your high-tech thingy. Yeah. Yep. Not possible. My right?
All right.
Oh,
Reboot.
You give dead batteries?
Do we have batteries?
Or can I
Okay,
just,
you're gonna have to. No, I think that your computer is actually frozen.
Yeah, okay.
Ah.
All right.
Wait, hold on.
Yeah. Okay. Maybe now it works.
Yep,
Yeah.
it works.
All right. Cool. Thank you.
Sure.
So there's this other problem, which was a true problem that I've seen on various, first-party apps. So if you think about large object heap allocation, as you know, the large object heap is not compacted automatically, right? There's a mode where you can say compact large object heap in the next full GC. Well, actually that changed again in 3.0 as well, but you can read that elsewhere. So for a large object heap, it could either use the end of segment space, which would be a bump pointer allocation, or it could use the free list that we build up on the large object heap. Because we don't compact, it means we would build up a free list, right? We would see if an object is dead, we would make that object into a free object. Of course, if you have adjacent objects are dead, they would be made into a large free object. So that means when you're allocating, you are consuming this free list. And if we're doing background GC, right, that's our concurrent flavor of the GC, background GC is the one that actually threads up this free list for the allocations to use, right? So if a background GC is in progress, and while it's doing this threading part, it means it would actually sort of conflict with the allocator part, because they both need to consume the same list. There needs to be some kind of synchronization or some mechanism to make that work if we want to allow them to work at the same time. For a long time, our assumption was that, well, you just don't really make very many large object allocations. But of course, that turned out to be not the case. Because if I look at various customer scenarios, it's not often that people do make a lot of large object heap allocations. So, but before 4.7.1, I think, when this went in, we just basically said, while the background GC sweep is in progress, we just don't let you allocate large objects. So you just have to wait. If you happen to want to allocate a large object while the background GC sweep phase is happening, then you need to wait until the sweep phase is done, right? So that was, if you look at Purview, you might have noticed this table called LH allocation pause due to background GC greater than 200 milliseconds for process X table. And one of the reasons is waiting for BGC to thread free lists, right? So I started seeing more and more pauses because of this reason. So I really wanted to do something about it. So how do you fix this? Well, we observed that usually sweeping the small object heap takes way longer than sweeping large object heap, Because if you look at the large objects that people allocate, generally they're very non-pointer rich or reference rich, right? So small object heap, if we did this study in all the dumps that we had to see like how pointer rich objects are on small object heap versus large object heap. It turned out that it's way less on large object heap because usually people would allocate things like byte array, right, on large object heap. So sweeping those is very cheap, right? All you do is, you see an object on the large object heap, you say like, is it marked by the background GC? If it is, I need to keep it. If it's not, I know I can make this into part of a free object. And if the large objects generally just, has a bunch of byte arrays, you just, go from object to object header, it's pretty quick. So it was kind of a shame that we actually stopped the large object allocation while we're sweeping small object heap, right? Because that's where you wait the longest. So then I said, well, if we had a different log, a separate log for large object heap, that would be a fairly easy fix, right? Because I only need to take this log if I'm sweeping, or while I'm sweeping the large object heap, which is usually fairly quick. So now you don't have to wait while we're doing the small object heap sweeping. So that was, this is the simplistic way to describe it. Of course, there's complications, as with concurrent GC, there's always complications. But this reduced the Bing backend latency, their P95 latency by 10%. So that was pretty good. Because before that, I noticed that we have specific events that would fire if a large object heap allocation needed to wait specifically for this reason. So it was pretty clear that this team was hitting that. So it wasn't that surprising that it improved the P95 latency by 10%, which is really good. So there's better ways to fix this, but more complicated. So when I actually did a fix, but it didn't really make into the product because it was too complicated and too late. Basically, the idea was that during the background GC sweep, we actually had specific points where we would say like, let's check if a foreground GC is happening, right? Because one of the major characteristics about a background GC is like, while it's in progress, we would check to see like, hey, does any thread want to trigger a foreground GC? If it does, then we'll let it happen during those points. And those points are very often. So you could imagine that instead of just saying like, let's only allow large object heap, like while background GC sweep is going on, let's only allow large object heap allocation to happen while we're sweeping the small object heap. We could also say, while we're sweeping a large object heap, we can take advantage of these points and say, like, now we can synchronize with the large object heap allocator and allow those allocations to happen at those points, which would be obviously way more often than now. So that was a pretty good result. I'm fairly happy with this, what I saw because of the change that happened on desktop. Right. So another thing that I mentioned was provisional mode. Right. So another customer came to me and they said, hey, we see a lot of full blocking GCs happening, compacting GCs happening when we're running in high memory load situation, right? So I looked at it, I was like, well, you see a lot of them happening because you have very, very heavily pinned Gen 2. So what this team was doing is like they did a ton of network I/O, and these I/Os are very long-lived. So when we compacted Gen 2, we discovered that, well, we just couldn't move all these objects, right? So there's a bunch of fragmentation that was created because of pinning in Gen 2. And we have this, GC recognized this condition when you see that the physical memory load is greater or equal to 90%, right? So at 90%, we say like, oh, looks like we're pretty short on physical memory. We better do something. We better do like more aggressive full GCs to attempt to not get you into page-in situation, right? Because not getting into page-in situation is extremely important. And when we say physical memory load, we mean if you're running standalone, right, on a machine without being in a container, that would be your, how much physical memory is consumed. And if you're running container, we have a different calculation. Basically, we just take the memory limit that you specify, then we can check the working set of the process that's running in that container and compute it that way. And as I mentioned, one of the configs that I ported was the GC high mem % config. So you could use that to change this 90% number. So if you have a big machine, right, this particular team, so their process is fairly, I think their process had a 2 gig heap, and it was running on the same machine as this other process that was consuming way more memory, right? So the machine is, it's a big machine. They had probably 64 gig at a time. And for them, if we're in 10%, for their process, that's plenty of memory, right? Because of 6.4 gigs, and their whole process only consumed 2 gigs. So they're like, this is one of the things I added for them, where they could use this to specify that for me, I actually would only recognize the GC, or I would only want GC to recognize as high memory situation when it's, let's say, 97% or 98%, right? So that worked well. But when they actually get to that point, they're, again, seeing a lot of full GCs being triggered. Because what GC was doing, that it thinks that, okay, I'm in high mem situation, which means I'm really going to be very aggressive with the full block and GCs, the compacts, right? And it would do one and would discover that, well, the situation is not much better because I couldn't really shrink the heap due to the pinning, right? So this new provisional mode would recognize when we're in this high memory situation, and as you do Gen 1 GCs, if the Gen 1 GC at some point actually would cause Gen 2 size to increase, meaning that, okay, when we did the compaction, right, in Gen 2, we would build up a bunch of free lists that can accommodate the Gen 1 survivors into Gen 2, right? That's called the allocating into Gen 2, right? And unless that allocation actually consumed all of the free lists, it would actually not increase the Gen 2 size. So we're still okay. So we can wait until this actually happens, and then we say, like, next time, after we're out of this Gen 1 GC, we would actually trigger Gen 2 GC right away, because we know we can't let it go further without risking it to increase the Gen 2 size, right? Because at that point, not increasing Gen 2 size is kind of a major goal for us. So this is what the provisional mode said, that during the Gen 1 GC, it would actually detect this situation that says, like, I'm in this Gen 1 GC, I'm about to increase the Gen 2 size, and I recognize I'm in high memory load situation, and I recognize that your pinning is really a lot of pinning going on in Gen 2. So if all those conditions are true, it would put GC then in this provisional mode, and then it would trigger Gen 2 compacting GC next time. So this means that we're the most efficient possible when we're in this high memory load situation at not risking increase the Gen 2 size. So, so that worked really well, actually. I think they used to see something like, if they're in this high mem situation, they would spend something like more than 50% in GC time because it was so bad. And after the fix, I think they were spending less than 10, so like 7 point something %. So that was a happy result for them. Right. So another config that I ported is for large object heap threshold, right? So I had been hearing from various people that, well, your 85,000 byte threshold is just too low, right? They want it to be more. And originally I was thinking, like, yeah, we should do, my plan was, let's run a bunch of, perf scenarios, because, we got tons of teams at Microsoft where we can just say, like, hey, can we get you to run some, perf runs and tell us, like, whether increase into some certain number would be better, right? But the thing is, like, obviously, as you can imagine, for different scenarios, it works very differently. For some people, maybe if you increase it to 2 megs, it works the best. For some other people, maybe it would be 8 megs, right? And it completely depended on what is your allocation pattern? What is your survival pattern? What is the kinds of large objects that you're allocating? What do they look like? So I ended up just doing this new config. However, it does have a limitation. You can only make it bigger. So some people say like, oh, why can't I just give it any number I wanted? I think it would be nice, but considering the return that I can get on this new config, for the time being, I think it was, I was already happy with the return I was getting by only allowing it to be bigger. So what happened was some customers, they would actually allocate frequent large objects that are very, that are like byte arrays, right? No references. So what it means is that they would set this to be bigger. Let's say like they observe that they allocate 8 megabyte byte arrays all the time, right? And let them die, so they're very temporary. So originally this was not good at all, because that means they would need to trigger a lot of Gen 2 GCs, right? As you know, that large objects are collected because they're logically considered as part of the old generation. They would only be collected when we have a Gen 2 GC. So, previously they were triggering a lot of Gen 2 GCs. I mean, these might be background GCs that may not have much of an impact on the pause time, but they consume CPU, right? You still want to cut down your CPU time spent in GC. So, with this threshold, basically they're saying like, I'm going to set the threshold to, let's say, 8 megs, right? So that means like the temporary large objects they allocate now is actually considered, they're part of Gen 0. Right, so they're collected very often. And it doesn't really increase Gen 0 collection cost by that much because they're fairly cheap to collect, right? Objects are really expensive to collect, or pointer-rich objects. You hold on to a complex object graph, which means GC would have to chase the pointers, and when we relocate, we have to relocate a bunch of pointers. But if you just have these flat objects, GC just needs to look at basically at the header to calculate some properties about this object and be done with it. I mean, obviously we'd have to relocate this object itself, but we don't have any pointers inside that we need to relocate. So that worked out really well. So then, especially if you also have a big Gen 2. So if you have a big Gen 2, especially because they're very pointer rich, and you have temporary large object allocations, this increase in this would really benefit that scenario. So, okay, I just covered this. And one of my customers actually nicely added this new profiling API, so you can actually get this threshold. Although I know that not too many people are using profiling APIs, but at least you know this is an option if you would want to get it. There's also another thing added for profiling, which is previously we had this flag called, this long thing, except there's no large object in the middle, which said that put the runtime into the mode where every time you allocate an object, I would get notified if I'm writing a profiler with this flag on. You can imagine how much more expensive that is compared to if you didn't do this, right? Because every single object, if you're ever curious and glance at our runtime code, you see all these like super fast allocation helpers that we hand-tuned with, some of which were written in assembly, that we really tried hard to make the allocation cost low. So by turning on that flag, you're saying now all that is out of the window. Now we're going to go through this very slow object allocation helper. So that would obviously increase your the cost by many folds. So with this new profiling flag, you're only asking for object allocation monitoring for large objects, which are already fairly expensive to allocate anyway. So this makes a much more practical usage. Okay, then I want to move on to another topic, which is containers. So, as some of you know, container scenario was one of the things that was complained about a lot in 2.2 and prior. I think this is what some people wanted to do to me, but fortunately not for real. So I totally get that some of our customers were really angry because it didn't work well, especially if you have a container with a fairly low memory limit set, and you're using, like, for example, server GC. And a lot of our customers obviously are using ASP.NET or ASP.NET Core, and that would automatically, by default, turn on server GC for you. So if you're in a situation where you have a container, you've set a fairly low memory limit on it, but you're running on a machine, actually a very powerful machine with, let's say, 48 procs, 48 cores, right? So by default, if you do not actually limit the CPUs this container can use, and server GC would just think that, well, I got 48 cores to use, I'm going to create 48 threads. So if you set the memory limit to, like, say, 200 megs, it's not going to work well, right? So that's a scenario I knew it wouldn't work well. And I was sort of promised there would be other people working on it, but that didn't happen. So at some point, I just kept seeing more and more complaints from people, and I was like, okay, I'm just going to work on this. So I took a look. I mean, the general idea was there. You know, you have a large machine where server GC was designed to want to consume as much resource as possible on this machine, but suddenly it's very severely limited by a certain aspect of this resource. So that wouldn't work well. But if we want to talk about details, well, here's some of the reasons why it didn't work well. So first of all, a lot of the decisions are made during the GC, right? For example, one thing that GC wants to make sure is, like, if we're going to do a GC, let's make sure it's productive, obviously, right? We don't want to do unproductive GCs. So how do we check if doing a Gen 2 is going to be productive? We use, various tuning parameters to say, like, hey, if, for example, if we're in high memory situation, right? So if you set your container limit to be very small, it's very likely that GC kind of always thinks that you're in high memory load situation, because now we use the memory limit that you set on this container as the total memory we can consume, right? So one of the things that we had in GC was, well, let's check to see if we were to do a compacting GC, how much space can we get back? If that space is too small, then we're going to say, like, well, we're just not going to do a Gen 2 even when you're in high memory situation, because we don't think it's going to be productive, right? GC doesn't just, like, blindly do all sorts of Gen 2 GCs because we're in high memory. We still want to be as productive as possible in that case. So the parameter to check whether it's productive or not did not really make sense when you're in this situation. It would end up thinking that, yeah, like, based on the situation I think I'm in, there's just not enough fragmentation to make this Gen 2 worthwhile. So I'm not going to do a Gen 2. So that's not good, obviously. And another reason was that when we need to expand the heap. So during the GC, if we see that, well, our small object heap is too small to accommodate more allocations on the heap, we would say, like, let's expand the heap. What that means is just that we're going to get a new segment, and that new segment is going to be our new ephemeral segment. So the Gen 0 and Gen 1 objects would live on that new segment. So when we make this decision, we just think that, well, we're only going to be, we're only reserving space, right? Because getting a new segment means we're going to ask to reserve that much memory. We don't actually commit most of it. At that point, we will commit what new Gen 1 looks like on that segment, and that's it. We don't need to commit more. And that also didn't work well, because we're now in a very different situation from before, right? If you only have one segment, that segment is almost full, we had a kind of tuning for that. But if you now have another segment that's mostly not full, we have very different tuning for it. And that part didn't really work well. And we also have this other tuning thing. There's a lot of tuning things going on in GC that would actually downgrade a Gen 2 GC to a Gen 1. So at some point, when we're doing a Gen 2 GC, we would look to see, did it seem like we actually were able to shrink the Gen 2 size? If we're not able to, we would say we're going to put GC in some certain mode that we don't want to be doing this too often. Right, so in this case, we would say, let's actually do mostly Gen 1 GC instead, since we cannot shrink Gen 2 anyway, and doing a Gen 2 is so expensive, right? So that part also didn't work well. because of what that caused was we would then downgrade to a Zone 1, and because we didn't reclaim enough memory, now our out-of-memory logic would say like, you're out of memory. So you see out-of-memory errors. So there's a bunch of reasons why the previous logic didn't work well. And another thing that happens in the allocator code path was that the allocator would, at some point, decide to trigger a GC, right? The allocator would say like, let's look at how much memory we still got on segment, and if that doesn't look like it's sufficient for a little bit, right? GC doesn't check per object, because that would be very inefficient. So GC generally says like, I want to leave a little bit of a space available on the ephemeral segment for your small object heap allocations. So that logic that determines when we're out of a GC, did we get enough space for that amount of allocation we wanted, would tell us that if we don't have that amount of space, then we'll declare out of memory, right? We don't use until the very last byte, because that would also be, to need to make that kind of check would also be very inefficient. So we also have this tuning parameter that says, when we come out of a GC, if we don't have this much space, we would declare out of memory. And that tuning parameter also was not taken the right amount of memory in this container scenario into consideration. So sometimes it would declare out of memory even though we do have enough in this situation, right? So those are, this is not an exhaustive list, but this is some of it. So I sort of did various fixes for this. At the beginning, I wanted to still allow heap expansion. So I said, well, if we take our current implementation, right, that would first reserve some segments, and then at some point you would say like, okay, I need to get a new segment. So I wanted to allow that, but there are problems with that, because if you're on container, you specify this memory limit. What if I have multiple heaps that wanted to expand, right? Do we give each of them then like half of our normal segment size, or do we give one of the heaps the full segment size, but not the other one, right? So there are problems like that that just seemed like it would be much easier if I would just actually reserve the whole space up front, because I know exactly how much space I'm allowed to use, right? Previously, I did not know that, right? Some people have suggested, well, why can't you just use like the whole machine memory as your limit? But that means every single process would think that way. That would also not work. But if you're telling me that your process is supposed to, or is allowed to use up to this amount, I could just reserve that space up front, right? So that's what I did. Right, so instead of using our normal segment size, like if you look at the GC code, there's a number that's defined to mean the normal segment size for small object heap, right? So I would actually just compute this based on the limit that you specified instead. And then in the allocator code path, there's places where we would say, let's commit more memory, right? So GC would also not commit only what it needed at a time. Let's say you're handing out allocation quantum amount of memory, right, which is, let's say, 8K at the time. GC would actually commit more than that, and it would let the allocation quantum consume what it committed and until it runs out of that. So because committing is actually an expensive operation, right? So we also don't want to do that very often. But by the virtue of that, that means I could afford to add a little bit of more cost onto that commit code path. So what I did was, when we actually get to the commit, I would check against the limit at that point. So I could afford to take the synchronization cost. So that kind of guarantees, right? As long as you didn't lie to us, right? We have run into situations where people said, you're allowed to consume up to this amount of memory, but then we try to go commit that amount, and then we get out of memory. So that's the scenario. Actually, I was not handling that well, but I did make a fix. Right, so also, there's tuning parameters for like segment size and allocation budget, so we also took that into consideration. One of the things that I did was, I actually don't allow the segment size to go too small, because it would be kind of ridiculous if you have this many. Again, you don't specify the amount of, or the number of cores that your container can use, but you give it a very small memory limit. I don't want to get into a situation where each segment ends up to be like 1 meg, right? That would also not be good. So the segment size is 16 megs minimum. And of course, since we're only reserving, we're not committing, we would only commit up to the limit, what the limit allows us. We also compact large object heap if needed. So if you're running in a container situation with the memory limit specified, it means your large object heap would actually get compacted automatically. And we also tracked GC's own bookkeeping cost against this limit. So previously, that was, it's a lot smaller than the actual GC heap. But still, if you're in a fairly low memory limit situation, we want to really make sure that we're counting things correctly, right? And there's one thing that I added was we actually added a new allocation state for a large object heap. So the GC allocator is this, we have a state machine for small object heap allocations and one for large. So it's a fairly complicated state machine. And for this, I added a new allocation state that would tell the caller to say that you need to retry this code path. So that kind of makes a good opportunity to talk about how GC actually chooses what heap to allocate on. Right? We don't need to do this retry if we only have one heap, because you've already done the, there's no other heaps to retry. So this only applies for server GC. I don't think I have time to get into too much detail, so I'm just going to talk about kind of high-level things here. So if you have multiple heaps, right, and you're allocating on your user threads, and we want to find a reasonable heap to make the allocation on. So there's a few things that you can think of that would make sense, perf-wise. So one is, obviously, we want the allocation to be local to the core that you're running on. So we tend to keep you on that core for a while, right? But if you are running into a situation where you look at other heaps, they're just a lot emptier than your heap by a long shot, then it makes sense to go to that heap, because for server GC, we like to keep the heaps as balanced as possible, which means that when the server GC threads actually do the work, they can be kind of done at approximately the same time. And that's what we want, because we don't want to be in a situation where some threads are already done their work, but other threads still got a bunch of work to do, so they have to wait on each other. I mean, we do have work stealing and all that, but we try to keep this the work as balanced as possible from all sides, right, including the allocator code path. So if we do notice that other heaps are a lot emptier than your heap meaning the heap that corresponds to the core that your allocating thread is running on, right? So we would actually go to that heap. We also have NUMA considerations. So if you are running a NUMA machine, which means the remote node cost would be higher than local node memory access, right? So in that case, we would also move your allocation to a remote NUMA node if it makes sense, meaning that that heap would have to be way emptier for us to want to go to that heap to allocate, right? So there's a bunch of perf considerations like this. And notice that this choosing part is actually not done under a lock, right? So when GC actually makes allocations on the heap at some point, it's going to take memory from some heap. That part is absolutely needs to be done on the lock if you want to allow multiple threads to allocate on the same heap. But this choosing part doesn't have to, because it's sort of, it doesn't have to be completely accurate. Because it would be okay if you had, let's say, your segment is 128 megs, and one heap only allocated 124 megs, while the other heap allocated like 127 megs, right? I don't think people would really complain about that case. So this means that when we actually go to the heap to allocate, the situation at that point could be different from a little bit ago when we looked at the heap to do our to determine which heap to allocate on. So you could be in this case where when you looked, you're saying like maybe heap 3 looks like a good heap to allocate on. But before you get to allocate on heap 3, some other thread already got to allocate on heap 3, right? That thread got the log first. So now you go there and you discover that I actually don't have space on this heap anymore, right? This could happen a lot more often in the container situation that I just described. So with this new alloc state, this says that if this is the case, which means that I come to a heap when the previous, the choosing part of the code told me that I should be allocating on this code, thought that there's enough space. But when I actually try to allocate on this heap, I discover there's not enough space. But I observe that my total consumed memory is still under the limit. That means I need to retry, right? So then it would go back and choose the less empty, the more empty heap to allocate on. So that was the new allocation state that got introduced with this feature. Okay, so there's another thing I wanted to mention, which is large pages. So with the introduction of this, I should mention I actually internally call the container support hard limit because you're specifying a hard limit. So yeah, this is implicitly set if you're running on in a container with the memory limit set. So what we do is, if you have a memory limit set, we would by default take actually 75% of that as our default hard limit. Because we have to consider that you're still going to have some native memory usage, right? And we don't really know how much that is. So we had to think of a number, and we came to 75%. And I've had folks that actually run into a situation where they used to not get out of memory, but now, because we're only taking 75%, now they're getting out of memory. So in that case, you could use the hard limit config yourself to set the limit back, right? So with the implementation of this, there's one thing that came out of it, which is now the allocation of the GC heap is really just in one place. Because we reserve memory upfront, so we have this one place where we say, we're going to reserve the hard limit bytes of memory. That's it. That's all the segment initialization that's ever going to occur, right? Because we don't allow heap expansion. That means the code path that does the heap expansion now is not going to get hit if you're in the hard limit config. So one of our customers came to talk to me about the large page support. I actually have a video that I did with him last month that got released, I think, a few days ago. So it's on my Twitter account. So if you're interested, you could go search for it. So he came to talk to me, and he's like, could we add large page support? Or why don't you have large page support, right? So I said, well, actually, it had been on my to-do list for a while, but I didn't do it for some other reason, which I explained in the video. But now, because the initialization of the GC heap is only limited to one place, and in order to use large pages, you do want to get them kind of during the process startup phase, because later on, you'll have a much harder time to get them, right? Because large pages, they're very limited. You'd have to say, I want to dedicate this much memory to large page usage. And later on, when the pages are getting fragmented, it's a lot harder to acquire them. So if you're going to use large pages, the general practice is you just grab them at your startup time, which fit really well with the hard limit feature. So he actually did the PR for this. So we provided an option which you can enable with the config that says, I want my GC heap to actually be allocated on large pages. So the current state for that feature, well, the result of that is really good. This is also one of the Bing teams, and they saw an 18% P95 latency reduction, which is really huge. The current state for this particular feature is that the GC heap can be on large pages if you specify the config, but the GC's own bookkeeping is not. Just because work that we have to do, which we're actually currently doing right now. So I also wanted to put the GC's own bookkeeping data on the large pages, because that could also provide benefit. So more support is coming, and I expect in the next version we should definitely have the option to put GC's own bookkeeping on large pages as well. So this is also not enabled through the runtime JSON. So if you want to try it, you'd have to use the CompPlus environment variable, which I'm sure is not a problem, right? All right, I have about 10 minutes left. So I also wanted to mention a little bit about our future focus, because I'm sure you're interested to hear that. So one is, I hope this is obvious, we're continuing our work to reduce latency, right? It's a big part of our work, and there's various aspects that we concentrate on, right? When people think latency, a lot of time they think like Gen 2 GC latency. But if you look at it, our Gen 2 GC latency is actually quite good if you keep doing the background GC. These days, I hardly see very long latencies when you're just staying in background GC mode. But we actually start seeing like now the ephemeral GC pauses can be big, relatively, right? So if you see like ephemeral GCs that take quite a while, meaning that you can decide what quite a while is. But I would say if you see it in the 100, like more than 100 milliseconds, that's definitely I would think that's way too long. So you're welcome to find we have PerfView, which is an excellent perf tool that would help you with analyzing the GC pauses. And we're also open sourcing our internal GC perf infrastructure soon. So that would make a lot of analysis much easier for you. If you notice on GitHub, we actually used it to look at this one customer. He had he sent us a trace, ETW trace, with the necessary GC events, right? It's a verbose level GC events. So we, one of the devs that works with me, he used the infrastructure to look at it, and he was able to pinpoint pretty easily like what the problem was. It's because they had a much higher priority threads running in the same process that was preempting the GC threads, so GC threads couldn't get time to do its work. So we're, I'm really hoping that the open source will happen very soon. Another thing I really wanted to achieve is that we know that we have to make some perf trade-offs, right? With the GC, often it's about, well, if you tell me you can give me more memory, that means I most likely don't need to spend as much time in GC, right? Because I can afford to delay the next GC now. But a lot of the time, it's not just like either you want 100% of this perf characteristic and not that, or you might say like, oh, well, I think the most important part for me is % times CPU time in GC, right? I really want to not let GC use too much CPU. Or some people might say like, I can afford to give GC maybe 15% of the CPU. So you just feel free to consume up to 15%, but I want to keep my individual latency low, right? Or you want to say like, I really memory footprint. Maybe I want to fit tons of containers on the VM, and I just really would want my process to use little memory, but still with acceptable perf, right? So one of the future directions that we want to go is to allow the users to communicate to us these perf, like how important one or more of these perf aspects are to them. So you could say, this, how you would define this is unclear to me at this point, but it would be something like, hey, I want you to concentrate 50% on percent time in GC and 30% memory footprint, or you could say I want you to just concentrate on the percent time the CPU in GC, and that's really the only thing I care about, right? So there has to be some way for the users to communicate this to us. And of course, then GC would try to do the best job it can to satisfy these requirements. One of the things I experimented with actually a couple of years back, that's when I started, is to use a closed feedback loop to sort of regulate the GC heap usage. So if you think about what we're trying to achieve, if you say the memory, the size of the heap is the most important to me, I really want to keep my GC heap at this size if possible, right? So that means that many factors could affect the heap size, right? For example, we have a generational GC. So maybe suddenly your Gen 0 starts to consume a very significant part of the GC heap due to whatever factor, pinning, whatnot. So that means there's a lot of disturbance going on. But you have this, in the control theory term, it would be your set point, right? Set point says my output should be at this value. So you calculate some parameters to try to stay at the set point. So we started experimenting with that, and I'm also kind of considering machine learning for this, which may or may not pan out. We don't know, but that's a new area that we're looking at. It's actually quite exciting to me. So that kind of concludes my talk. As I said, it's not an exhaustive list of what we did in 3.0, but I hope you sort of got a lot of the implementation or some design ideas that happened that were fun to hear about. So if you have any questions, please ask Meow.
I have a lot of questions, but probably I just didn't understand this case about containers.
Okay.
You said on our laptop, for example, we can't reserve all the memory because we can have several processes that could ask for all the memory.
Right.
But why is the case about containers is a special one?
Because in the container scenario, if you're actually specifying a memory limit on it, you're telling us that specifically for this process, you can use up to this much memory, right? So obviously, you should not be doing something like if you had 10 gigs of memory, you specified 10 gigs on each of the 10 containers you're running on this machine, right? So you say okay, I'm going to specify 1 gig per container. So the sum would be 10 gigs. Then GC knows, okay, there's no danger if I'm using up to 1 gig. Whereas if you don't specify a memory limit, container is really just a way to say you can specify some sort of limit, right? Resource limit. If you don't specify any kind of limit, then all 10 processes would think that I can use up to 10 gigs. That's not good, right?
But we can have 2 processes.
Yes.
And each of them will think it can be
So,
10 gigs.
In general, I don't really encourage people to use 2 equivalently active processes in one container. It's always been a problem. With Windows, it's the same thing, right? Actually, the earliest, we still called it job support because job is the Windows term for containers. So people would run multiple processes in the same job without using CLR at all. That didn't really work well because, it's very often that both processes would think I have this much limit. It's hard to say out of the limit, what am I supposed to use in my process, right? So most of the time, folks just ended up, they would only run either one process in each container or each job, or they make sure that only one large process is running in that job. They might have little processes that that's why we're taking like 75% by default, right? So we're saying like you might have other usage that we don't know about. So, sure. Yeah. Any other questions? Yes.
On one slide there was an information that you have some logic that allows Gen 2 downgrade to Gen 1.
Yes.
Does it mean that Gen 2 will be treated as frequent as Gen 1, or what's happening?
That just means we're doing a Gen 1 GC instead of Gen 2. So when we pause for GC, right? Yes. Oh, I'm sorry. Yeah. So the question is for people online. The gentleman asked when you the logic that I mentioned that would downgrade a Gen 2 to a Gen 1 GC, would that mean now a Gen 2 GC is as cheap as a Gen 1 GC, right? Is that your question?
Yeah, but Gen 2 stay as it is, right?
No. So okay. So I think I understand what you're asking. So this all happens when we're still in the process of deciding what generation we should collect, right? So when a GC, most of the time GC happens because you've exceeded the Gen 0 allocation budget, right? Allocation budget just means like this number that we set on this generation that says when you have allocated this much memory into this generation, we should trigger a collection on that generation. Right. So for you, from the user code's perspective, let's leave out large objects for a minute. So you're allocating a bunch of objects in Gen 0. That means you're consuming the Gen 0's allocation budget, right? So at some point after you've exceeded this number, we say like, okay, we need to trigger a GC. So pretty much, I mean, not strictly speaking, but pretty much the first thing that we stopped when we triggered a GC is to decide what generation we should collect. And if it's a Gen 2 collection, should it be done as background GC or block in GC, right? So this whole like downgrading Gen 2 to Gen 1 actually happens during that process. So at that point, the actual GC work, the mark, plan phase, they haven't started yet. So during this process of deciding what generation we should be collecting for this GC we're about to do, this is where that logic happens. So as we would go through a lot of factors during that process and say like, hey, this factor, if we hit it, would make us, elevate from a Gen 0 GC to a Gen 1 GC. Because most of the time when we trigger a GC, it starts as a Gen 0 GC, right? Because you just exceeded the Gen 0 allocation budget. So from there, we would say like, we look at the factors that we want to look at. Then we say like, these factors would make us want to do a Gen 1 GC instead. And these other factors would make us want to do a Gen 2 GC instead. So at this point, we could be saying we want to do a Gen 2 GC, but then we could hit that logic that says you need to downgrade to a Gen 1. So then this GC that actually starts would be done as a Gen 1 GC, not a Gen 2. So.
Can we reverse it, like upgrade it as needed?
Sorry?
Can it be upgraded as needed?
Oh, right. So there's always factors that would make us want to either make the generation number go up or down, right? So there's some factors that say that right now you're at the point that you are at a Gen 1 GC, right? So we're still in the method that determines what generation should condemn. It's called generation to condemn, if you're curious to look at it. Well, generation _to _condemn, obviously. So, so it's all during that process where you could be going through some factors that says like, if you were already doing a Gen 1, so far you've decided you want to do a Gen 1 GC. Some factors would make us want to say like, if these are true, then we would want to upgrade this Gen 1 GC to a Gen 2 GC, right? So then there's also the logic that I mentioned would make us want to downgrade a decision we already made to do a Gen 2 GC to a Gen 1 GC. So, yeah. Yes?
Please, two questions. First, is implementation open? Do you have some links which I can follow to see the project which you described?
Is the implementation open? Yeah, this is all on GitHub. If you go to github.com/net /CoreCLR.
In what file?
If you don't know that, I'm not sure why you're here. Seriously. Yeah.
Second question regarding the testing process. So you have mentioned about one performance metric, P95.
Mm-hmm.
So how many metrics do you have, and much time it takes to run all of that?
I'm sorry, are you talking about the P95?
Yeah.
Right. So the question is like, what's this P95 metric that you mentioned?
How many do you have? Like
How many? Actually, this P95 is from the Bing group. So Bing.com, search engines, usually their gold index is a P95 latency, right? So if you have a search engine, you want to sort of report this P95 latency, meaning that you measure the requests as they come in, and you measure it when they're done, and you take your P95 latency. That's what they want to optimize for the most. So their job is to see that P95 latency going down. That's something that makes them happy. So it's really from Bing Group. It's not from us.
And how do you run it?
How do they run it?
Yeah.
They actually just measure on their production machines, right? So Bing.com has, I don't know, probably hundreds and thousands of machines. They would measure the request latency and say, obviously most of the requests finish very fast, right? Then when they do all the measurements on their own, and they look at the P95 request latency, and then report the number. So Bing also has, Bing has many teams, right? And when we say Bing, we don't just mean like one team. There's all sorts of teams in the Bing group. So they have the P95 latency for the front end, for the back end. I'm sure there's other groups that contribute to this latency. And each part, I'm sure, is trying to get the P95 number down. So they also have some perf tests, just regression tests, right? So like the Bing, one of the Bing teams, they actually take our daily builds, which is yay. So they would take the daily builds. They would run this build through their sort of sanity check perf test suite, which would tell them like for the test, for the things that this test can simulate, the P95 latency did not regress, right? Before they actually deploy the build onto some obviously low percentage of their production machines, then I would just measure it there. That's how it's done. Yeah.
So are you satisfied with the results, with benchmarks?
Am I satisfied with their? Well, I'm still here working, right? So that means we still got room to improve. Yeah. Yeah. Any other questions? Yes.
So it seems that you spend a lot of time looking at customers' issues and feedback from customers.
Mm-hmm.
So could you do a breakdown of your work time, how much time you spend on HL coding, how much time you spend on looking at customer issues, and how much time you spend on some architecture planning work?
Okay, this is a good question. The question is, how much of my time is spent on feature work, design, implementation, how much of it is spent on customer issues, and there's all sorts of other work that I do, which is I actually spent quite a bit of time in the past few months with the dev that works on our perf infrastructure to have a good infrastructure. Like we used to have one, obviously, but I really want a new one to take advantage of newer technology and make our work more efficient. And the fact that I sort of used to be a one-person army, so that it's very different when you're working as a one-person army to a four-person army. So so now I try to get more time to do the feature designs or long-term thinking where I couldn't afford to do as much before when I was just one person, right? So as far as a breakdown, it's hard to say because day to day it's very different, right? These days I would say I generally try to kind of distribute the work of like, there's always perf issues that we need to look at because if there's customers that come in, especially the ones that say, well, we're about to ship and you need to help us look at this memory issue. And most of the time it turned out to not be in GC at all, but we still gotta help them to figure it out, which is where I think the perf infrastructure would really work because the important piece that we have in there is the analysis piece, right? So I'm hoping that we'll get to a point where instead of us using our perf infrastructure to help some team to look at their perf traces, we could just say like, hey, just go, use our analysis piece and figure it out yourself, right? So I think I don't really have a accurate breakdown, but I'm hoping that I'll get more time to work on the features and implementations now that we have more people working on GC. Any other questions? No?
I have basically a related question about customers. You introducing more and more parameters in the process.
I'm sorry, more and more?
Parameters. More and more inputs in the code.
Yeah.
Haven't you thought about to introduce some deep learning stuff?
Well, I mentioned.
Empower it for a customer. You mentioned.
Right, I mentioned that as part of the new experiments that I'm doing. It includes like machine learning, which, as I said, may not or may not pan out because there really hasn't been. You know, if you think about the GC tuning itself, it requires a ton of sort of domain knowledge, right? We have at basically each step of the GC, right? If you look at the mark phase, then we do the, you know, if we're doing a block in GC, we go through mark, go through plan, which sort of does a simulated compaction phase. Then we decide whether we need to compact or we need to go to sweep phase, right? So if we do compact, we have 2 more phases to go. If we do sweep, we have 1 more phase to go. So at each point, we would make some sort of perf decisions, right? Like for example, in mark, one of the things that we do is, if let's say we're doing an ephemeral GC. So one of the perf parameters that the ephemeral GC measures is that when we mark through, you know, so there's various sources of objects or routes that GC has to mark from, right? You know, you're familiar with like stack routes, GC handles, finalized queue, right? So if you're doing the ephemeral GC, another type of routes that GC has to mark through is the older generation objects, right? Because if you're doing a Gen 1 GC, by definition, you're not collecting the Gen 2 part. And that means Gen 2 all needs to be alive. Whatever they refer to all needs to be alive. Right, so we would mark there, and one of the perf parameters that we look at is when we're doing that, if you were looking at Gen 2 objects and you observe how many of them are actually pointing to Gen 1 versus Gen 0, right? So if we observe like, hey, there's actually a lot of the Gen 2 objects have references to Gen 1 objects, that means next time we want to do a Gen 1 GC at least, right? Because that would make it more efficient. We would rightfully promote these things into Gen 2 if they survive. And then at plan phase, we make decisions about whether we should, you know, important decisions, whether we should compact or not, right? And then, so at each point, there's like a lot of knowledge that GC has in order to make these decisions. But of course, the reason with the incentive with machine learning is like now you can run this in tons of different customer scenarios and you can observe because, you know, from one scenario to the next, you know, any number of factors could affect the outcome of the GC, right? You know, how your object graph looks like. Like even if you have the exact amount of memory, you could behave very differently from one scenario to the next. So the machine learning part would actually adapt to, we're hoping that would actually adapt to the scenario that's running it, right? So that's definitely something we're experimenting with. Yeah.
We have a question online.
Yes.
Someone else wants to.
Oh, all right.
13x Forever asks,
okay.
will these changes propagate to .NET Framework 4.8 eventually?
Yeah.
Or are we waiting for 5.0? Large memory pages sound nice for some workloads.
Yeah, so you kind of need to take up with our management for that. Yeah, basically. Sorry?
You can answer that question in the panel discussion.
That's true, yeah.
I can answer.
Yeah, well, but the general idea is, you know, as we know that we've announced that we're kind of encouraging folks to move to .NET Core. So the likelihood of moving features back to full framework is based on business needs instead of happening automatically. You know, maybe Carol can add more, you know.
Managerial stuff, yes.
Yes, right, yeah. Oh, yeah. Oh, I'm sorry, you had a question.
Yeah, I wanted a question to ask, actually, how do you test all these different changes that you're doing? You have a lot of features. Right,
that's definitely a challenge.
A lot of flags, you know, you have a lot of environments. How do you test it?
right. So that's why I really wanted to do this new GC perf infrastructure. I'm sorry? Oh, yeah, right. The question is, I'm sorry, I keep forgetting. Yeah, the question was like, you mentioned a lot of like tuning stuff that you're doing. How do you test all of this, right? Do you run, so what we, and I started saying that that's why I really wanted a new GC perf infrastructure. Because like previously, we had a fairly static collection of tests that we ran. So like, if I made a change, you know, we ran through this like hundreds of tests that measured various things, and we say like, did they improve, did they regress, and blah, blah, you know. So that was proven to be sort of just not very scalable and hard to change things. So for example, you know, if I had 2 different perf tests and I wanted to add a certain scenario to one, right? Obviously, these 2 different tests would do different things, but if I want to, you know, add the same thing to both, I'd have to either make a library, have them both use it, or add, you know, duplicate code, which obviously was not desirable. So I really wanted the new perf infrastructure that just has one sort of a mega simulator type of thing. So that means that, you know, we just basically run this with different configs. So we would say like, do you want, you know, what, you know, first of all, one of the biggest complaint that I had with our old perf infrastructure was that a lot of the tests were adapted from sort of functional tests, right? So especially if a customer said like, oh, this test was not, you know, working well, or you know, our scenario was not working well, I've extracted a test for you, can you make sure this test works well? So we did that, and then we just added it to our perf suite, right? So what that meant is like, we sort of, you know, you have to, you know, remember like what this test is for, because, you know, it was not very well documented either, right? And one of the really severe problems with that was these tests all had very different live data size, which meant like live data size meant if you were to do a full compacting GC to get the heap to the smallest possible, what is the size at that point, right? So if you're at a steady state, usually, I mean, not always, obviously, usually you have a stable live data size. But we need to know what that live data size is. So, you know, when I used to have a tester, I would ask them, like, what, you know, you're telling me this is out of memory, but what do you expect to be the right amount of memory usage for this, right? So in order to answer that, they'd have to go through each test and figure out what the number was. So like one of the first things I added to this simulator thing was you can specify a live data size. So you just say like, I want this test to use a live data size as 5 gigs. So the test itself, while doing other things that you've asked for, if you were to do a full blocking GC or a full compacting GC at basically any random point, it would come roughly to, you know, 5 gigs, right? So that's like, for example, one of the things that we did. So we would use this to specify various configs that would exercise different perf aspects of GC, or perhaps together, in order to test it. So what we did when we open sourced this, you'll see. So what I did was, you know, I worked with Andy to figure out a set of scenarios that you want to run if you were to make a perf change to the GC. So these kind of act as the sanity check for perf. Right? What it means is that, you know, we have a basic scenario. Like, for example, if you just allocated pure temporary objects, what the behavior is, you know, obviously you don't want to regress that, right? So then we have actually a container scenario. So you could run things in a container and make sure that works well. And then we have a high mem situation, which I talked about, which is obviously very important as well. So we have a few of these scenarios that act as the sanity check. You know, these are the things that we're doing with the perf infra. Yeah. So I think I'm running out of time. All right. So.
So as well, for the folks online, we're gonna do a quick break, bio break, and that stuff in, let's say, 10 minutes, because we ran a little bit over time. Let's get back. You can continue asking questions about hardcore GC or, you know, about general.NET Core, and we're gonna try to answer that with Maoni as best as we can.
All right.
Will it work? All right.
Good.
Thank you, Maoni, for a great talk. Thanks. All right, so we promised to do .NET Core discussion panel. So we're gonna try to field questions, Q&A. You can keep asking questions about GC. We actually got some feedback from, I believe, Nick Craver. Hi, Nick. On GC that he loves. What did he love? On. Do you remember?
Limits.
Yeah.
Oh, the limit thing.
Limit thing, yeah.
Yes.
He's pushing the limits of GC always and everything, right? Thank you, Nick. We love that. And otherwise, anything .NET Core, .NET, try us. If we don't know, we're not gonna answer. And actually, one thing actually we can start with. I heard a question that somebody asked actually if the GC changes will be in the .NET 4.8 or in the .NET framework or .NET 5.
Mm-hmm.
So now that I'm on the microphone, I can actually answer or continue your answer.
Your management.
Management version, yes,
Right.
yes. So the management version is the same as Maoni said, that the 4.8 or .NET framework is really, there needs to be business need, like significant impact. And there's actually a great article, blog post from Scott Hunter. I think that it's probably from May-ish or something like that. If you look it up, you can read on that. And all the changes actually that are happening in core will be in .NET 5, because if you read about .NET 5, .NET 5 is basically the next version of .NET Core, and the 5 version as well tells everyone, including people who didn't quite follow the core, that like that's the next version, that's the future, that's where the things will happen. Yeah. So, questions? No.
I think that you're here. There's no question.
Because me.
Yeah.
So should I go? All right.
So start one which combines the GC and the .NET Core. So basically, when you started with the .NET Core, how much work was needed to basically move from Windows, from the GC perspective, to support also Linux and the platforms?
Yeah.
Let's repeat the question.
Well, okay. So how much work was needed when we open source and we needed to support Linux in addition to Windows from the GC's perspective? Yeah. So actually, I had a blog post written about this, around that time. So there are definitely things that we knew that like certain OS features that we use on Windows that we were looking for on Linux and could not find the equivalent. So we had to do some work to amend that. So essentially, we provided our own implementation of such features. We learned some surprising things about memory management in Linux that we had to accommodate, right? Like for example, in Windows, if you say, I'm able to commit this amount of memory, you're guaranteed to not ever get out of memory if you want to use it. That is not the case on Linux. So we had to accommodate that. And yeah, there's things I wouldn't say a ton of work because GC, the thing about the GC is like, it doesn't really make a whole lot of, there's OS calls that we have to make to acquire memory, right, to do certain memory operations, but there's not all that much that we do. Most of the GC code is very portable. If you look at GC code, syntactically is really simple. I mean, it just does some computation here and there, and yeah, sometimes kind of.
to Maoni, it's simple. To the rest of the world.
Syntactically.
Yeah. Didn't actually Jan Worlicek work on that? On the Linux part of the GC?
I can count.
Okay. Yeah. Sorry, I was trying
to
do a shout out to him. So.
Jan Worlicek, like he just mentioned, Jan is our so GC has an OS layer that calls into, right? So because GC is supported on both Windows and Linux and Mac, we have actually abstracted the OS functionality that GC needs into their own layers. So for example, when I say like high memory load situation, like as far as how that number is calculated, GC just gets a number from the OS layer, right? So on Linux, it would call a PAL layer and say like, get memory load, just get me the memory load. So obviously that layer will then implement correctly or desirably what the memory load that it would pass to the GC.
I always said that like Jan Worlicek is actually
over
here in Prague, probably not watching online.
So Jan is the owner of the OS layer. Yeah.
All right, we have
question from the chat. Does Maoni have any tips on where to start if I was looking to get my hands dirty with the .NET GC?
So I would, sorry. Oh, do I still need to repeat the question?
I don't think
you
that you're
already,
good. Yeah.
you already said it?
I think this should be fine.
Yeah. Okay.
Yeah.
Your turn.
Yeah.
Sorry.
Yeah. No problem. Yeah. So I would, I tell everybody who wants to learn about the GC is you read the page I wrote in the documentation directory in the book, The Runtime. There's a garbage collector.md, which lists the sort of the high-level ideas of the GC, right? So it also, one of the sections it has is the high-level functions of the GC code. So when you actually, at some point, you need to get into the GC code path, right? So where that is, what are the top-level functions in the GC? So like there's phases, like mark phase, mark underscore phase, plan underscore phase, and all these phases. So I would just set a breakpoint on them. Use a very, very simple test that allocates memory, that you know what trigger GCs, which you can verify with our perf tools, obviously, right? But if you allocate memory, like if you keep allocating, you will hit the GC code path at some point. So just set a breakpoint on those functions and just debug it. That's how you learn about it. That's how I learned about it. Yeah. When I first joined the CLR group, I actually did that. First, I did that on a loader code because people said like, oh, the loader is really complicated. So I just used a very the test really didn't do anything at all. All it did was just hello world. So I debugged into a loader code path and I understood how that part worked well enough, right? Obviously, I wouldn't say I was an expert after that. But when I took over a GC development, that's what I did.
So that's interesting that when I started actually on the CLR team, Jan Kotas told me exactly the same tricks. There's the hello world, little thing, just debug it. And that's actually virtual club dispatch or whatever interesting kind of happens actually in CLR. That's a great way to actually learn. I think that even some talks, public talks from people who actually showcase that and show how JIT works and other stuff, not only GC.
Yeah. Right.
It's a great technique.
Yeah.
Maybe easy question, but why do we have 3 generations in small objects?
Why do we have
3 generations?
I don't understand.
5
generations.
3 generations.
3 generations. Why there are 3 generations?
Why do we have 3 generations in small object heap? Yeah. So there's a generational hypothesis, right? As we know that in the memory world. So the hypothesis says that either you allocate very long-lived objects, right? All your statics, all the things that people, when the process starts up, generally they would allocate a bunch of objects to store some kind of state that they would refer to later. And then when they're actually doing the work in the steady state, they would allocate very temporary objects. So that says that there's these 2 groups of objects that have distinctly different lifetimes, right? So that gives you the idea of Gen 0 and Gen 2, right? Gen 2 is the long-lived objects, and Gen 0 is the very temporary objects. But we also had Gen 1. Gen 1 kind of if you think about when a GC happens, right? I always use server apps as an example, just because I mostly work with server app folks. So in server app, it's very common that you have requests, right? So if you imagine what happens in requests, generally you would, when the request starts, you would start allocating a bunch of objects that would only be used by this request, right? But when a GC happens, right, GC doesn't really have any idea about your requests. So it's very likely that, between the last GC and this GC, maybe you had, 500 requests, let's say, right? But the 500th request that's still in flight, and the GC would happen in the middle of it. So by design, so far the objects you've allocated only for that request would survive when we do a Gen 0 collection, right? So GC actually has different tuning things to sort of recognize the situation. So some of our coworkers actually asked me, they're like, Maoni, is it true that when you have a Gen 0 object that survived a GC, the generation is always Gen 1? And I said no. And then they said, what? So if we, yes, that's what they said. When GC sees that there's just a little bit of memory, compared to some amount, relatively little, it would actually keep that memory in Gen 0. So it's not necessarily true that when your Gen 0 object survives a GC, it's always going to be considered as a Gen 1 object. So we do that because we observe that, that's helpful in catching the in-flight objects. What that means is that next time, if you want to get rid of the in-flight objects, you only need to do a Gen 0 GC. You don't need to do a Gen 1 GC, right? Because if we actually promote it to Gen 1, then that means you'd have to do a Gen 1 GC in order to get rid of them when they become garbage. And then Gen 1 acts as a buffer that says well, it's just sometimes you will have survivals from the temporary objects. It's just a fact of life. So Gen 1 sort of acts as a buffer between the very old generation, very young objects, and then we would collect some of those objects in that generation, and that would be collected later during the Gen 1 collection, instead of having them promoted into Gen 2.
So Gen 1 is for accidents, basically.
That's a bad word.
Okay.
Describe it. Yeah.
Why don't we have, for example, 5 generations?
So the question is, why don't we have 5 generations? We actually tried that. Didn't really give us anything. So we discovered that 3 actually was the optimal number.
Measure.
Yeah.
That's the only way to do perfect.
Yeah. It kind of makes sense if you think about it. Yeah. Yep.
Cool.
Any other?
You make it sound so easy, by the way.
I cannot say it in one sentence. Isn't it related to the cache levels of the processor and this compactification of memory? Isn't it anyhow happens to make more memory, more useful memory fit into the process cache?
So what I heard the process cache part. What was the part before that? I'm sorry.
My question was when we're trying to make more useful memory in less space. I'm speaking about compactification. And is it for purposes to keep more useful objects, more live objects in the processor cache?
So I think, correct me if I'm wrong, you're asking that, is it beneficial to keep objects in the cache if you can, to make it fast? Absolutely,
yeah,
right.
But does GC help?
Absolutely, yes. So when we based on your previous question, we established that it's very often that you allocate very temporary objects. So one of GC's goals is exactly to do what you just said, we better keep the temporary objects in the cache. So GC expresses that by the Gen 0 budget, allocation budget. So what that says is that when we calculate the minimum Gen 0 budget, right? So when a GC happens, of course, a GC always collects Gen 0. So that means when it collects Gen 0, it's going to calculate a whole new set of dynamically tuned perf parameters for Gen 0, right? So one of them is the Gen 0 allocation budget. And this budget says, if you allocate this much in Gen 0, you trigger a GC, right? So we want to allocate what the cache allows us, right? Because you can keep more in the cache, but not exceeding that, kind of. That's the idea, right? So we want, that's why Gen 0's min budget is a portion of your last level cache. That's exactly for this reason. Of course, if we observe your survival rate is fairly high when we do a Gen 0 GC, which means you're going to get out of the cache anyway. So there's no point to be limited to that small size, because that would mean you will trigger GCs more often, right? So at that point, we will adjust the budget higher. Yeah.
My last question is it's about the same. My final destination question is when we run .NET Core application on the system with less level of cache, for example, two levels of cache on Qualcomm processor or something, maybe 1 level of cache.
Okay.
But on .NET Core we have predefined these 3 generations. I mean, we cannot reduce or increase amount of generations. Does it make sense to make it configurable for them?
So does it make sense to make configurable
amount of generations?
Number of or size of generations? Number of generations?
Also size and also
size
number.
Based on the system cache, OS level cache, processor cache.
So it's when GC calculates the min budget for Gen 0, it already takes the last level cache. So So if you only have 2 levels, then it would take the L2 cache. If you have 3 levels, which most of the Intel processors do, it would take the largest cache, and then would do a portion of that. Yeah. Does that answer your question?
Yeah.
Okay, cool. Yeah. Yes.
So you mentioned some customer scenario where you had a lot of pinned object on generation 2.
Mm-hmm.
You said that was caused by implied network requests, and
that's not what I said.
Sorry. So,
yeah.
Like I assumed it could have been from implied network requests, and this could potentially cause some fragmentation in the generation 2 heap.
Mm-hmm.
And I was thinking whether you explored for this scenario doing some pre-allocated memory pools, which wouldn't get fragmented as much.
It's funny that you mentioned that. Actually, oh, sorry. How come I cannot remember this?
It's hard.
Right.
It's
so, I'm not used to having to repeat what someone already just said. But yeah, so the question was that the scenario that I described where there's a heavy pinning in Gen 2 that caused a lot of fragmentation. Would it be beneficial, or did we consider that we would maybe group these pins together so they don't cause so much fragmentation? So funny that you would mention that, because I just checked in the design doc for the pinned heap maybe a month back. I think I announced this on Twitter. So we would have a pinned heap where you, so the problem originally with pinning was because you are allowed to pin any object that you already allocated. Right, someone or some library that you used allocate this object. At some point, you can say, I have a hold of this object. I'm going to allocate a pin handle to pin this guy. Right. So that means that we had no control over where the pins are at that point. I mean, obviously, you could say like, well, why don't you consider you could provide some API to say like, when you pin this object, you have the option to move it somewhere. We could do that, right? But the design choice that we chose was we're just going to have this pinned heap because based on our customer feedback that a lot of these are from like library authors, right? So they're happy with providing the option to say like, I'm going to allocate and pin at the same time. So that makes it cleaner because it's definitely doable to say like, at this point, I'm going to move the object, but it's a lot cleaner to say like, I'm just going to allocate and pin on the pinned heap. So that's actually a feature we're working in right now. Yeah. Yep.
Question from the chat. You mentioned objects always start at Gen 0. Is there a mechanism to tell the GC to put an object directly on Gen 2?
Yes, so I actually did that. So first of all, it's not completely true, right? If you allocate a large object, it would be in Gen 2, right? Because Gen 2 logically is part of, large object heap logically is part of Gen 2. So if you allocate a large object, it's directly in Gen 2, right? So we've had, over the years, I've had customer requests that said like, why don't you provide an annotation of some sort that let me specify like, I want my object to be directly in Gen 1 or Gen 2, and we've definitely had that request. So first of all, as I explained, like when we do a feature, we have to consider the returns on this feature, right? Because each time you add anything like this, it kind of adds to the maintenance burden of the GC, right? I try very hard to not add things that we think would become such burden, but without all that much return to us, right? Because all the, every time you complicate the GC code, obviously that, in a way, that is a maintenance burden, right? Now you may have just introduced some new limitations that, GC would have to maintain in the future. But I actually have an API proposal on GitHub that would, the new API would allow you to allocate directly into Gen 2. So that's definitely something we're considering.
Okay.
So, yeah.
Well, I guess that we're probably waiting for customer feedback and really like some demonstration that it's gonna pay off and it's gonna really get the advantages for, pay off for the burden that we're gonna maintain.
Right. So some of the customers I mentioned that, one of or multiple customers have suggested this annotation thing that they're like, I can do the profiling guided thing that I will tell you which generation to put it in. But it turned out like as soon as they moved their scenario to a different machine, to a different workload, they observed that the numbers that they figured out were no longer true. Because, you know, imagine, like, let's take Bing as an example, because, you know, we work with Bing a lot. So Bing has, you know, when we...
You like them, right?
So when you type something on Bing, I'm sure same with Google too, you know, it's not just one type of query, right? There's text-based queries, there's image-based queries, there's a ton of different kinds of queries. So when you move, you know, for example, and regional could play a factor too. Like apparently I was told that if you go to like North America data center, you actually observe a different usage from like European data center. Like I heard this from both, you know, Bing and Exchange folks. That, you know, Exchange have like data centers in, you know, all continents, obviously. So they actually observe differently because, you know, they have all different types of requests, and people from different regions tend to use them very differently. So when you have a process that handles, you know, all like 30 different kinds of requests, right? You could have, if people who use those machines have different habits. Like some people apparently tend to love to use online email. Some people love to use the Outlook client to check their emails. So that provides a different mix, and apparently that makes a different memory usage pattern. So yeah, so it's that's where that request ended up.
But everyone comes and says like, oh my, you know, I know how it is. My scenario is the most important, and then it's actually in all perf, or like we see it outside of GC as well. Then
yes.
You start measure, start getting real. It's like, yeah, it's not quite right.
Yeah.
You know, it's the world is more complicated and not that simple.
Yeah.
So.
Yeah.
So one question for .NET Core 3.0. It's going to be released in days. How stressful is that for you? Or just polishing the code, or are you working nights?
So how stressful is .NET Core 3.0 end days? Because in a few days we should release. Stressful for us. Was it a question for directly Maoni or general? All right, for both. Do you want to answer your part first?
I mean, at the...
She's here, by the way, so you know.
Right.
She's fine.
So it's, you know, I'm on the runtime team, right? Carol's on BCL, so he's a little bit higher level than. So on the runtime team, we actually, even though .NET Core 3.0 is supposed to release on, I think, September 23rd, something like that.
That's .NET Conf like next Monday.
In days. How about we stay with in days? Because clearly I'm not, you know. So
we didn't say which day because it's 3 days conference, I believe. So,
right.
So that's
yeah.
that's why.
Yeah. So the runtime team actually already got into the mode where we're not really allowed to make changes unless you have approval from management way before that.
A higher management, like not just management.
Right. So like I actually, the last few changes I wanted to get in actually didn't make it. Like for example, I said that config, that people are saying like this name doesn't sound polished, and you know, which I mean to me is okay, but you know, that's, when it comes to naming, different people have different opinions. And it was a little stressful to get, I had to sort of not check in, you know, the last major checking I made was to the many core, so perfect improvements on many core machines, right? So we were, and you know, many of our like internal customers are expecting large, you know, many core machines coming, like especially with the AMD to make a big splash, and you know, their new processors. So I wanted to make, you know, there's some scalability issues with when you run on that many cores. So I wanted to make a bunch of changes on that, but I had to really weigh the risks and not actually including all the things I wanted to check in, because, you know, there wasn't enough time to you know, it was just too risky. So, yeah.
Another answer is like if you look at the Core CLR and Core FX repo, you will see how stressed we are, like, you know, or, you know, because you will see how many PRs actually go into the branch. And like any software development, if you want to ship on some date, if you're date driven, which is kind of reasonable, because if you give loose dates, then developers tend to just add more and more thing, and you never ship, like constant beta. I think there was a company that did that like quite a lot. You know, so you kind of tighten it down and say like, you know, let's get more serious. And obviously, like, you know, a few days before shipping, I think that if we don't have like final builds somewhere ready, we're in trouble. Like some people are now stressed in engineering system, by the way, engineering services team. Tomasz is from that team. So,
yeah. think, yeah.
Okay.
So most of your roadmap that you mentioned before was about reducing the latency for the garbage collector.
Mm-hmm.
Do you also have targets for heap sizes to support very large heaps or something, or does that work already?
So yeah, like as I mentioned, like in my second, I mentioned that one of the most important goals that we have is latency reduction. But the question was like, do we also have heap size goals, right? How large of a heap? We definitely think about that. So part of the latency reduction work includes that when you're running on a very large heap, how it behaves, right? So for example, when you consider a concurrent GC, right? So one of the things that concurrent GC has to do is, this is, if you read this in papers, often people tend to try to not make this part sound as serious as they should, because it sounds very stressful, and it doesn't make their hypothesis work. So, but if you think about like the concurrent GC, obviously you have to account for the heap modification from the user code, right? So if you have large heap and you allow a lot of heap modifications to go on, you have to somehow account for that, right? That's cost to process all the heap modifications. And of course, we already process a large portion of heap modification concurrently, right? So we have a specific thing that we do as part of the concurrent GC where, this is a part that we can also, I think we can also do better on, which is like, when do you say that we would finally stop for that that final mark phase, right? At the end of the background GC mark phase, we would actually stop you one more time, but usually that pause is very small. But you could imagine that if I have a very large heap and allow you to go for very long, that heap modification, and you keep modifying the heap, right? Because you could process concurrently as much as you want, but while you're processing, the user code is modifying the heap again. You obviously have to account for that, right? So there's various techniques we can do. For example, one thing we can do is to throttle that modification, right? So we could say like, in the write barrier code, we just don't allow you to run as fast. That's one way to get you to come to a stopping point, right? Which is okay from the user's perspective. I mean, obviously, it would slow down your throughput by a little bit, but that's one way to get us to a better point when we need to reduce that last phase's pause, right? So there's definitely, that's the large heap size is already part of the consideration for latency reduction. Yeah. Does that answer your question? Somewhat.
What I was mostly trying to figure is like, if you look at Java, they have a lot of large heap collectors. Most of them basically trade off, as you said, the cost of writes by basically reducing pause times, which means your garbage collection in total gets slower, but you never stop.
Yeah.
And from my understanding, is it takes a lot of runtime changes to make that possible.
It can. It depends on what you do, obviously. I mean, you could imagine doing a simple thing like, let's just go to write barrier code and just slow down you a little bit, right? That would work already. That would already help some. In general, like when we do this kind of changes, we tend to do them incrementally, right? There's no point to go very complicated if the smaller steps already get you a lot of gains, right? So that's where we would start. Yeah. Yep.
I wanted to ask you about the diagnostics. I mean, in general, .NET's core, GC and whatever. So I guess ETW was the main source for collecting different types of diagnostics for years. What is the story now? I mean, when we have Mac or Linux.
You know the answer? I have like half answer, so correct me if I'm wrong. So ETW does not exist on Linux. So oh, thank you. What was the question? How do we diagnostics in .NET Core and with ETW for every part of .NET Core? So ETW is on Windows, but at the end of the day, actually we started using event source, and I don't remember exactly the technology on Linux, but we basically abstracted that entirely.
Event pipe.
Okay, come here and I'll answer that, okay? So this is we take Karas and he's smarter, so
no, I'm just working on it. So.
Okay. Well, there we go.
Hello. No, that's okay. So on Windows, you can still use ETW, but under the hood, it's called event pipe. It's a new mechanism which is the same on all platforms. There are tools like .NET Trace, just search for that, which can collect the event pipe data from any process on any platform. It produces a file which you can then open and preview, even if it was produced on Linux. And there are ways to convert that data into other formats which are consumable by tools which are more like Linux friendly. And on Linux, if you're specifically running on Linux, you can also ask the tracing system to use LTTNG as the backend, and then use whatever LTTNG tools you want. LTTNG is like a similar mechanism to ETW, which is native to Linux.
Well, one of the technologies, but the one that we chose to.
Yeah.
Yeah, I remember that one.
I mean, you can still use ETW on Windows. So well, I'm a perf person, so when I talk about things, I always talk about the perf of it. So as of today, we definitely have some perf discrepancy between our event pipe implementation and, for example, ETW. So because ETW is a native thing to Windows, right? Windows has optimized the hell out of it. Whereas the event pipe, first of all, it doesn't, as of now, it does not give you the native portion of the call stack.
Yeah.
Right? So if you collect the call stack, you would only get the managed portion. Right,
because we work the stack, like the runtime itself.
Yeah, right, yeah. So, which is something that I've been pushing the diagnostics guys to do, because I care about.
You just push this guy.
Okay. Yeah. Well, you're here. It's easier for me to push the guys.
Okay.
Right?
Yeah, that's true.
So, but we're definitely working on that. Like, there's definitely you know, for example, if you can collect CPU samples, right? So if you go to .NET Trace, if you search in our repo, we have a page that specifically describes Linux perf diagnostics, right? So that includes .NET Trace, which came out in 3.0. If you were to use that to collect CPU samples, it would, every time you collect a CPU sample, it would actually stop the managed threads, right? So you would see, if you were looking at the events view in perf view, you would see a lot of suspend EE events with each of the sample collection. So, you know, on Windows, you obviously don't need to do that. So, yeah. Something I wanted to mention in case you look at it, you're like, how come I have so many more suspend events now? Oh.
Thank you, Vita.
Does that answer your
Please be on standby, just in case. So I have a special, you know, does anyone have like, you know, one sentence question? Special bonus for that.
Trying to form your question into one.
Nobody?
I have one sentence.
All right.
So if you wouldn't work in IT, what would you do? What would be your other job? Both.
Panel discussion, so not only the hardcore GCQ&A. So.
Oh.
Thank you, Lucia. So the question, like, what would you do if you wouldn't be in IT?
You want to answer first?
I have no idea. So mathematics, I guess. Yeah.
I think I have a couple of options. If I'm not doing STEM-related things at all, I mean, obviously I could go to another STEM field, but you know, I could go to hardware. Hardware is very interesting. But if we're talking non-STEM, I think my top two choices would be fashion designer and comic writers.
Yeah.
So I really love. So
that's what I guessed.
I like drawing, and I think making up a story. Like I have some favorite, like Calvin Hobbes. I don't know. It's an American. Yeah, it was my favorite for yes, right. Yeah, I love.
Thumbs up.
Yeah. So you know, to draw a strip. You know, episodes, right? You know, and then you make up stories that go along with it. It just seems like a really fun thing to do. So, yeah.
Myself, you know, well, I said mathematics and math. Like, honestly, I did like set theory at school. I actually loved that.
What about non-STEM?
Non-STEM. Yeah, thank you. That's, you know, I think I would find a job where I can talk, probably. You know.
I see.
You know, I could succeed that.
That is not surprising.
Thank you.
That's why we managed it.
No, I think that I could enjoy any organizational stuff, like even non-profit and the stuff I did that, you know, helped my wife actually, like, you know, some time ago, actually, I just like make things happen. So, cool, thank you.
Yeah.
Another one?
I think you had a question, but you were
multiple sentences, so let's try that.
Okay, so actually I like that in .NET Core you rethought and completely redesigned some things. And related to the GC, when we're talking about the managing this garbage, there are usually we have two options. It's just reference tree when we're trying to find unreached objects, or there's a automatic reference counting. There are some languages with automatic reference counting, and the question is, did you have any thought about this approach? And probably you have any research or some thoughts, is it useful or not? And,
right, I think I definitely got the second part of the...
So please ask questions that we can easily repeat.
So I think at least the second part of your question was, have we thought about automatic ref counting, and would we think that would be beneficial? Actually, some other gentleman just asked me that during a break.
it was me.
Yes, right. I was.
Yeah,
right. Yeah. So, and my answer to him was that I can definitely see the ref counting. When I say ref counting, obviously it means automatic ref counting, right? It's sort of like some people think this is a term that people debate. Some people don't actually call automatic ref counting a GC, but to me, you can call it the GC. I have no problem with that. So if I had a ref counting GC, I believe that would be a good auxiliary to have in addition to what we have today. Because if you think about the trace in GC is operating on it's betting on when it compacts, it can get a bunch of objects back. So you better be allocating all the temporary stuff, right? So the cost is proportional to the survival, right? Whereas ref counting is the other way, right? So it would be great if we had a ref counting GC on the older generations, because it wouldn't make sense. Gen 2, if you have a very large Gen 2, it would make sense that to have a ref counting GC there. But at some point, you'd have to, well, in theory you don't have to, but in practice you kind of need a trace in GC to help with collecting cycles and compacting the heap. And so yes, I definitely see the merits of it. But I would not do that as the only GC that we have. Yeah.
So I'll have a similar question. Maybe I missed part of the talk, I apologize on the meeting. But did you talk about actually regions and that stuff? Are we going to do that? Regions?
So are you talking about having regions instead of
yeah, hey, I start my request, I know that I'm going to throw it away, start of region, allocate, end of region.
Okay, you're talking about the arena.
Arenas, okay, sorry,
yeah,
regions.
Right.
Yeah,
so we did this, we had some experiments with arenas. And the idea is sound, right? You start an arena, you say here's the allocation I want to make in this arena. At some point you say I believe that I don't have any references to this arena anymore, you can reclaim it. Unfortunately, we cannot just reclaim it because the users, they often lie. Not intentionally, they just don't know that they still are referencing the objects that they claim that they no longer need.
But right? I don't write bugs, right? Everyone says that. Everyone says that, but nobody succeeds.
Maybe you say that. Yeah.
No, I never do.
Yeah, so,
I'm a realist.
What we discovered was because .NET framework or .NET Core, right? There's a lot of libraries written on it. The usage pattern, if you observe, that it's actually very likely that we call this as an arena leak. That means that when you claim that arena can go away, we go in and look because we just can't trust that there's no leaks.
We double check.
We double check and we discover there's leaks. So we actually, in our perfect experiments, even with scenarios where people tried really hard to say I really am telling you that you can let this arena go, we still found leaks. So that obviously made the cost or the benefit of arena less attractive. So,
but that's one example of features that we actually considered, experimented, measured, and then decided it's not worth the complication. Benefit is not that high.
We have to consider the gain that we can. Yeah. I mean, even when the idea sounds great, right? It totally makes sense, but in the end, you discover that in our particular framework, that's not as beneficial as you thought it would be.
I apologize, I'm going to ask one more question actually, Maoni.
Yeah.
Did you ever propose thing I'm going to do this feature, and then you kind of via measurement and stuff found out oh no, it's useless, it wouldn't pay off?
I'm pretty sure I did. I've experimented many things, so. Yeah, some of them did not pan out. Yeah, right. Yeah.
Okay, so you've mentioned arena allocation. Have you considered also adding features like allowing users to not allocate on the garbage collected heap, but also have off-heap storage? Or does
do you mean like I just have another heap that also contains managed objects, but the GC
managed objects?
Not managed objects.
So the question was, if you allow.
Not exactly sure.
Yeah.
Yeah.
So the question was like if we considered like allowing allocating on non-GC heap, which is like p-invoke, like you can do that right in native memory.
You can already do that.
Okay.
Yeah.
Yeah.
Right.
But that's native memory, like it's
right.
Well, you can then cast it to.
Can also so that we can hear. You just bring bigger chair.
That's okay. You can allocate, but you cannot make it what looks like an integer. Like you can allocate 12 bytes and say this is a string. That won't work. But you can get the memory.
We're running a little bit over time.
Yeah.
Oh, okay.
So maybe last question to whatever.
Yeah.
Quick, please. Not a long one.
Are there any differences in usage, like there is a C# and F#, different paradigms, and are there differences in garbage collection usage?
So there's, the question is did we observe any differences in the, patterns that in allocation or memory usage in F# and C#? For sure, yeah. So I looked at some, I don't know if you know of this website called jet.com. So jet.com is an e-commerce platform, and their backend is written in F#. And these folks, they really love F#, right? So I believe if you go to our Channel 9 videos, you can find some interviews with jet.com folks. So when I looked at a profile from them, from a typical C# application, it definitely looks quite different. So for example, if we were to do an ephemeral GC, right, a young gen collection, in a normal C# application, one of the big, usually you can see a costly thing to do in those ephemeral GCs is to mark from the old generation to the young generation, because it's very often that people just have these kind of references, right? They have, because F# obviously uses a different paradigm. They copy a lot, but in C#, this is like one of the major costs when I look at the GC costs for young gen collections, which is why we're doing work as we speak to do the latency reduction for that part. When I looked at the jet.com profile, that part was tiny, like virtually none. I believe the little part they had was probably from some of the C# code that they had. So their cost of young gen collection is basically all from the stack roots, right? Which makes sense. So yes, definitely, for sure, yeah.
All right, so one last non-GC question. Or we're done. And we're done. All right, non-GC.
Not non-GC, it's about assembly load context.
Okay,
okay. I already asked people in Meetup all this stuff, and I cannot understand, is it a different space? I mean, is it a different, like a domain, or is it the same heap, and how you can switch between contexts?
So the question was about a new thing which was introduced in .NET Core, actually in 1.0, but now it's kind of heavily discussed, which is called assembly load context, and oftentimes we position it as a replacement for arguments, although that's not very precise.
Before you continue, there's going to be talk about it on Monday, by the way, from this guy. So, so shorten it, please.
Yes. The short version is, if you think about assembly loading, so when something in the code triggers loading an assembly, only at that point the assembly load context is considered. And so it provides isolation in terms of, I'm looking for my assembly reference, where do I go and where do I get it from? That's what the load context represents. And you can create groups and that way you create isolation where basically if you load a plugin, you can say this plugin is in its own load context, and so all its dependencies are going to come from this place.
Or you have different versions of the same plugin or something like that, right?
And in each load context, you can only have one version of a given assembly. By having multiple, you can then do side-by-side versioning, basically. This is very much unlike subdomains, where subdomains provided instance-level isolation, where you could have instances of objects, like allocated memory, which was associated with a given subdomain. This has nothing to do with that. The assembly load context is solely about when you're loading an assembly, where you're going to get it, and which version, and what.
Just kind of more load file kind of abstraction, I would say. And on top of that, actually, the subdomains as well allowed you to load in their context different things. So maybe some overlap is there.
If you want, I'll still after this, and we can discuss
it.
Yeah. Or on Monday, you know, or over here, you know, starting at noon, we're gonna have. I see. It's gonna be online again because we figured out how to do streaming.
Yay! So that gives me room for a final question from the chat.
Awesome.
Why are finalizable objects added to the finalizer queue during allocation instead of during the plan phase when they are detected as unreachable? The suppress finalize object header bit could be used here.
Wow. The what? Suppress? Suppress finalizer
Suppress
bit.
Finalize object header bit.
That sounds like somebody who opened up GCCPP during the talk and found out something. Wow.
Or I just
not sure where this comes from.
I just wrote a blog entry on finalizer when I was here. Because, you know, I was really jet lagged. And it was hard to do.
Yeah, I actually saw that. Yeah.
GC work. Yeah.
But you have lots of your answers are. I wrote a blog post about that. I like that.
Yeah. So the question is, why do we add the finalizable objects to the finalized queue instead of discovering them during the plan phase?
Yes.
The plan phase is only looking at the generations that we're actually collecting, right? So for generations we're not collecting, we have to put them somewhere, right? So, and we need to, you know, at some data structure we have to say these are our finalizable objects. So yeah, you just have to. I mean, it's just merely a place to say like these are the finalizable objects. And when we're going through them, we want, you know, if we were doing this in the plan phase, like let's say, you know, we do this in the plan phase for Gen 2, so we do have a view for all objects, right? But we need to discover them and then put them somewhere, because at some point there's a specific time where we only want to go through finalizable objects, right? So you have to report them somehow, right? We can discover them later, but then you need to put them in a finalized queue. So that's the answer.
Okay. All right. Thank you very much, folks. Thank you, Maoni, for actually coming. You know. One more shout out to organizers for making streaming happen. You know. Hopefully we will have more of these events, and you know, maybe more cool speakers will come over, or maybe Maoni will visit Zoo again and stuff like that. Right? You know, she loves zoos, by the way.
If you live in Prague and haven't been to the zoo, I don't know why.
Or if you live in a town which has a cool zoo and you want Maoni to come over, there's a way how to get her. Alrighty, thank you very much, folks.
Thanks so much for coming.
And we're gonna probably over here continue somewhere. So whoever is hardcore and wants to go for a beer or something, you can ask more questions.
All right.